Okay guys, today I want you guys to go over chapter 6.4 worksheet 2. This slide right here currently has the answers from last night's assignment. So if you want to hit pause and go ahead and check your answers, that would be great. Obviously, no work, no credit. If I know you have these answers in a video, I'm not going to be happy if you just wrote them on your worksheet, okay? So we're going to go straight to tonight's homework. So if you want to go ahead and write these on a sheet of paper, you will have these as your homework assignment. So we are going to extend our process of what we had previously of our order of operations and our exponents, and we're going to talk about exactly what we're going to do. So for example, number 2, it says 32 to the 1/5 power to the 5 power. So what we're going to do there is you're going to multiply exponents. So you're going to have 32 to the 1/5 times 5. So obviously what you're going to see here is those exponents cancel out. The 5's cancel out and you're left with 32 to the first. So your answer is just 32. Now I'm going to show you another way that we do that. Another way that you can do that, either way, is if you want to put this in power over root format, this is going to be the 5th root of 32 raised to the power of 5. Well, what number multiplied by itself 5 times is 32. That comes out as a 2. So what we have here is 2 to the 5th power, and 2 to the 5th power is 32. So I did the problem 2 different methods, but you can still get the same exact answer. Number 8. Number 8. Same exact concept, but go ahead and put on missing exponents, because what is most confusing about this problem is you don't understand where the exponents are and how many different bases you have. So if you rewrite this problem, what you're going to have here is going to be 2 to the 1st, y to the 1/2, times y to the 1st. So that means the 2 hangs out by itself, and what you're going to have here is these two y's are attached together by multiplication, so therefore you're going to add the exponents together, and this is going to give you 2 to the y to the 1.5 to give you 2 to the y 1.5. Actually, that's the same thing as saying 2 to the y to the 3/2 power. So if I go ahead and I redo this, this is going to make this 2 times the square root of y cubed. Well, my power of 3 is bigger than my root of 2, which means I'm going to go ahead and I can simplify this to make that 2 times the square root of y squared times y, which means this comes out as a y to give you 2y square root of y. Now technically speaking, I would need absolute value bars there because I have an even root with an odd power. So that means this would be done then. Moving. Same exact concept here for 12. We've done many problems like this before, except for the exponent was not fractional. So don't worry about it. Just go ahead and put this as a radical. So we're going to go ahead and make this the cube root of 27/8. And we're going to go ahead and put the exponent on the outside, because anytime you take an exponent, take anything to an exponent power, you're making the number larger. So what we're going to do here is we're going to make the number smaller. So we're going to find the perfect cube root of 27, the perfect cube root of 8, and then we're going to raise that to a power of 2. So what number multiplied by itself 3 times is 27? Well, that comes out as a 3. What number multiplied by itself 3 times gives you an 8? Well, that comes out as a 2. And those both get squared as well. So 3 squared gives you 9, and 2 squared gives you 4. Done. Okay, next. Well, you learn something new every day. You're going to sort this out. You're going to put numbers with numbers, letters with letters. So we're going to have 3 times 4 times x to the 1/2 times x to the 2/3. 3 times 4 gives you 12. And since those x's are the same base, you can add those exponents. Now, if you would want to, in your head over here, or in your calculator, you could simply type in 1/2 plus 2/3. I don't have my calculator with me right now, so I'm going to go ahead and I'm going to show the work, and I need to have a denominator of 6 here. So I'm going to multiply the 2 by 3, so the 1 by 3. I'm going to multiply this 3 by 2, so that makes that 4 to give me 7 6. So that means I'm going to have 12x to the 7 6. Well, what do we know? We know that this becomes the 6th root of 12 to the 7th, or x to the 7th. Notice that 12 has an exponent of 1, which is why it is not underneath that radical. So now I'm going to go ahead and I make this x to the 6 times x. This comes out as an x to give me 12x times the 6th root of x. And what must I add here? Yep, you got it. Absolute value bars. Why? Even root. Odd power. So that's number 14. On number 14, sorry, I thought it wasn't recording anymore. On number 14, they were attached by multiplication. Okay, number 15. Just like with number 14, 14 was attached by multiplication, so we added exponents. These are attached by division, so we're going to go ahead and divide. So 12 divided by 4, 12 divided by 4 times y to the 3rd, and now these are attached by division, so I subtract these exponents. 12 divided by 4 gives me 3, and over here, you can type this in your calculator, or you can go ahead and do it by hand. Denominator of 6, 3 times 2 gives you 6. 3 times 2 gives you 6 to give you negative 1/6. And this is y to the negative 1/6. Okay, well, where do those negative exponents go? They go to the bottom. So this is going to be 3 over the 6th root of y. Now, I want to make sure that you guys understood what I just did there, so give me a second. I'm actually going to make this y to the positive 1/6 so that you can see. Sorry about that. So the 6th root of y to the 1st. Now, I'm not happy with that because can we have radicals in the denominator? The answer to that is no, so we have to rationalize this and multiply by what we need. We have 1y in the denominator currently. How many more do we need to pull out? I have to have 6 total, right? So I'm going to multiply by what I need. So that's the 6th root of y to the 5th over the 6th root of y to the 5th. So this gives me 3 times the 6th root of y to the 5th over, how many total do I have down there now? 6, so that comes out as a total of y. So don't forget to rationalize that. Okay, good job. Next, number 18. As you can see in your homework, you're going to notice that number 18 is actually written incorrectly. So this is the wrong problem. This is the correct problem. The minus 1/2 is actually an exponent. So if you correct that on your paper, the next thing we're going to have to do here is we're going to multiply those exponents together. So this is going to be a to the 2/3 times negative 6, b to the negative 1/2 times negative 6. So this is going to be negative 6 times 2 is negative 12 divided by 3 gives you a to the negative 4, and this gives you positive 3. Put it over 1. A cubed stays, b cubed stays, and a to the 4th goes to the bottom. And that's done. Just make sure you change the problem on that one. I did that one with you just to make sure that you did that. Number 24. 24 is exactly the same concept. Okay, what we're going to go ahead and do here is we're going to put on missing exponents. So when we put on missing exponents, we multiply those through. 9 to the 1/2, x to the 4 times 1/2, half of 4 is 2. Y to the half of negative 2 is negative 1. So we multiply exponents. Okay, so now what happens is I go ahead and I say the 9 to the 1/2 is the square root of 9, x squared, and then where does the y to the negative 1 go? To the bottom. And what is the square root of 9? That comes out as a 3. 3x squared over y. Done. (26) Same concept. Putting all these concepts together here. So how are my x's attached? My x's are attached by division, so I'm going to subtract the exponents. My y's are attached by division, so I'm going to subtract the exponents. So in a sidebar over here, I'm going to go ahead and do my math. Again, you guys could be using this in a calculator. So this is going to give me the same thing as 3/6 minus 2/6. And this is going to give me 1/6. So I have x to the 1/6 power. And then y is going to be 2/3 minus 1/2. So this is going to give me a 6 here. This is going to give me a 3/6 to give me a 1/6 there as well. So this is going to be the 6th root of x times the 6th root of y. Now, because these both have the same index, I can marry those together to give me the 6th root of x times y. Done. Number 30. First thing you're going to do there, you are going to put on missing exponents. So if I put on my missing exponent, I have a missing exponent on the 20, on the 12, and on the 75. So this is going to be 12 to the half, x to the 4th, over 75 to the 1/2, x or y to the 5th. So this is going to be the square root of 12 times x to the 4th outside. This is the square root of 75 times y to the 5th. Now what I know about both of these is that this is going to be 4 times 3. This is going to be 25 times 3. The square root of 4 comes out as a 2. The square root of 25 comes out as a 5, and these can go away and cancel out. So you're left with 2x to the 4th over 5y to the 5th. Now, you could have, from the beginning up here, reduced that to be 4 over 25. X to the 8th, y to the 10th, to the 1/2 power first. And if you'd have done that, you'd have had the square root of 4, which is 2, x to the 4th over 5, y to the 5th. Same concept. That's all I have for you today. So your homework is going to be Chapter 6-4, Worksheet 2. All. Stay busy and make sure that you are paying attention. Any homework that you owe me, please place in the bin so that I can grade it.